What if I told you that 2,000 years ago, people built cities faster, better, and more durably than we do today with our computers and cranes? We tend to think of the ancient world as primitive, slow, and backward. But Roman engineers would have laughed at our long-term construction projects. They didn't just lay stones, they created a global machine for producing civilization that worked like a flawless conveyor belt from Britain to Africa. Their secret lay not in the muscle power of slaves, as is commonly believed, but in total standardization, logistics, and military discipline applied to construction. The Romans were the first to understand that a city is not a work of art, but a standard product that can be stamped out anywhere in the world. Watch this video to the end, and you will learn how exactly the Roman assembly instructions allowed megacities to be built in open fields in a matter of months. Are you ready to learn the truth about who really built the Roman Empire? We are used to seeing Roman legionnaires as killing machines, clad in armor and wielding gladiuses. But the reality is that for most of their service, these soldiers did not wield swords, but pickaxes, shovels, or carpenter's axes. The Roman army was not just a military force, but a giant construction corporation with the strictest discipline and perfect organization. A legion arriving in a new territory did not start with looting or fighting, but with a total transformation of the landscape to suit its needs. Every soldier was a trained engineer who knew how to mix concrete, pave roads, and build bridges. They did not need to wait for contractors or hold tenders, as the entire workforce was already in place and ready to work. This allowed Rome to deploy infrastructure at a speed that seems fantastic even for China today. The secret lay in the standardization of skills. A legionnaire from Syria could replace a legionnaire from Gaul, and the quality of the wall masonry would remain the same. Their knapsacks contained not only rations, but also tools for earthworks, saws, and baskets for carrying soil. Officers were not just commanders, but foremen who monitored compliance with building standards with the same strictness as they did the cleanliness of weapons. Violations of construction technology were punished as severely as sleeping on duty or cowardice in battle. It was this militarized construction that allowed Rome to consolidate its hold on the conquered lands forever, turning them into part of the empire. The barbarians could defeat a Roman detachment in the forest, but they could not oppose a Roman road or fortress. Construction was an act of war, a way to impose iron order and structure on a chaotic world. Every stone laid was a symbol that Rome had not come here as a guest, but to stay forever. Engineering training began with recruits who were taught to set up camp according to a strict plan in a matter of hours. This temporary camp was, in essence, a prototype of a city with streets, sewers, and defensive structures. If the legion stayed in one place for more than a week, the tents were replaced with wooden barracks, and the moats were reinforced with palisades. If the stay lasted for a month, baths, warehouses, and permanent headquarters buildings appeared. The speed of the work was ensured by a clear division of labor, with each centuria responsible for its own specific section of the wall or moat. No one loitered idly, waiting for materials to be delivered, as the logistics were calculated down to the smallest detail. The legionnaires worked in shifts, ensuring a continuous cycle of construction from dawn to dusk. Such intensity of labor was possible thanks to the high-calorie content of the diet and care for the health of the soldiers. The Romans understood that physical strength was a resource that needed to be used sparingly and efficiently. Therefore, they actively used mechanization wherever possible, employing cranes and winches. However, the main driver of progress remained the flawless coordination of thousands of people working as a single organism. It was not a chaotic crowd of slaves under the whip of a supervisor, but a professional team. Even after retiring, veterans received land in new colonies and continued to build cities according to the same military standards. They became the backbone of the local administration, introducing Roman technologies into the civilian life of the provinces. Thus, Rome's military machine became a machine of civilization, spreading comfort and order. This experience shows that discipline and standards are more important than brute force and quantity of resources. I'm very interested to hear your point of view. Do you think the modern army is capable of such large-scale creation, or is this a lost art of the ancients? Write about it in the comments, and don't forget to subscribe to the channel so you don't miss out on other historical phenomena. Guess how long it took to create a network that spanned the entire known world? Roman roads were not just beaten paths, but complex engineering structures that were as sophisticated as modern highways. Roman engineers understood that the speed of movement of troops and goods was the key to the survival of a huge state. They built roads not for years, but for centuries, and many of them still serve people today. The process of laying a road began with the work of surveyors, who used instruments such as grommets to create perfectly straight lines. They ignored obstacles, cutting through forests, draining swamps, and cutting down hills for the sake of a straight trajectory. A Roman road did not meander. It went straight to its destination with the relentlessness of a flying arrow or a marching legion. This required enormous amounts of earthwork, but in the long run, it saved days and weeks of travel time. The roadbed was multi-layered, resembling a layer cake up to 1.5 meters deep. First, a trench was dug down to solid ground, then a layer of large stones was laid for the foundation. This was followed by a layer of gravel and sand to provide drainage and cushion the load. On top, large, perfectly fitted stone slabs were laid, which were convex in shape to allow rainwater to run off. Water was the main enemy of the road, and the Romans learned to combat it with a system of ditches and drains. Drainage channels always ran along the sides of the road, carrying away moisture and preventing it from washing away the roadbed. Thanks to this, Roman roads remained passable in all weather conditions, whether it was autumn mud or spring floods. This gave the legions a strategic advantage over the barbarians, who got stuck in the mud on forest trails. Standardization also applied to the width of the roads. It was strictly regulated so that two carts could pass each other freely. Milestones were installed on the roads, ancient equivalents of navigators, indicating the distance to the nearest city in Rome. Post stations were built along the routes, where couriers could change horses and rest. This created the first global information network in history. The speed of message transmission over this network reached speeds unheard of in ancient times, up to 80 kilometers per day. The emperor in Rome could learn about a rebellion in Britain or an invasion of Syria in a matter of weeks. Merchants used these roads to transport goods, which led to unprecedented economic prosperity. Military patrols ensured safety on the roads, making travel possible for ordinary citizens. Roman engineers were also masters at building bridges, which were an integral part of the road network. They erected stone arches across turbulent rivers, creating crossings that stood for millennia. The famous Trajan's Bridge over the Danube was a wonder of the world in its time and a symbol of Roman engineering excellence. Tunnels were dug through rocks where it was impossible or too time-consuming to go around the mountain. Roads literally stitched together the diverse lands of the empire into a single political and cultural space. A resident of a distant province, stepping onto a Roman road, felt part of a great civilization. This infrastructure outlived the empire itself, becoming the foundation for the road network of medieval and modern Europe. We still use the routes laid out by Roman surveyors 2,000 years ago. Investment in roads was enormous, but it paid off in taxes, trade, and military efficiency. The Romans proved that logistics wins wars more reliably than even the bravest cavalry. Without this stone web, Rome would have remained just a large city-state in Italy. Do you agree with the statement that roads, not legions, were the real secret of Roman power? But roads were only the beginning. In the next chapter, you will learn the secret of the material that allowed the Romans to build buildings that stood the test of time. What I am about to show you is banned in 12 countries as a building standard because it is too durable for the modern consumer economy. I am talking about Roman concrete, a material whose composition scientists have been unable to figure out for centuries. We are used to concrete structures crumbling after 50 to 100 years, requiring major repairs. But the Roman Pantheon has stood for almost 2,000 years, with the largest unreinforced concrete dome in the world. And there is not a single crack in it. The secret lay in a special ingredient, volcanic ash, which was mined near the city of Pozzuoli. The Romans mixed lime with this ash and seawater, triggering a unique chemical reaction. Unlike modern cement, Roman concrete only became stronger when it came into contact with water. This allowed them to build ports, breakwaters, and bridges right in the sea, where modern materials quickly deteriorate. The chemical process inside Roman concrete continues for centuries, creating rare minerals that heal microcracks. When a crack appears in the concrete and water gets in, it activates the lime residues, which fill the void. It was a truly living material, capable of self-repair without human intervention. Modern engineers are only now beginning to approach the creation of similar technologies. The use of concrete freed architects from the tyranny of stone and brick, allowing them to create any shape. Now it was possible to pour huge vaults, arches, and domes, creating spacious interiors without columns. This changed the very understanding of space. Roman buildings became large-scale and airy inside. Concrete was cheaper than hewn stone and did not require highly skilled masons to lay it. The Romans streamlined concrete production by standardizing proportions and pouring methods. They used wooden formwork that could be assembled and disassembled repeatedly, speeding up the construction process. The walls were often faced with brick or stone, and the interior was filled with a concrete mixture with crushed stone filler. This created a monolithic structure of incredible strength, capable of withstanding earthquakes. The concrete revolution allowed Rome to move from low-rise buildings to multi-story residential complexes called insulae. Cities began to grow upwards, saving scarce land within the fortress walls. Insulae could reach 5 or 6 stories, providing housing for the huge population of megacities. These were the first real human factories in history, built thanks to new technology. Engineers experimented with fillers, adding lightweight pumice to the domes to reduce the weight of the structure. In contrast, heavy basalt cobblestones were laid in the foundations for maximum stability. This understanding of the physics of materials made it possible to create structures that pushed the boundaries of what was possible. Roman concrete was a triumph of pragmatism and a scientific approach to construction. Forgotten in the Middle Ages, the recipe for concrete was lost, and Europe returned to stone and wood for 1,000 years. It was not until the 19th century that humanity rediscovered this material, but it was never able to fully reproduce Roman quality. We build faster, but our buildings are not designed to last forever, unlike Roman ones. This makes us think about the priorities of our civilization. Roman concrete is an example of how a single innovation can completely change the face of cities and the lives of millions of people. It became the physical foundation of the empire, binding its cities together into an indestructible monolith. The irony is that the primitive Romans created an environmentally friendly and durable material that we can only dream of today. If you enjoy learning about such incredible technologies of the past, be sure to like this video. This will help us create more content about the ingenious solutions of antiquity. What if I told you that everything you believed about the manual labor of the ancients is not true? We imagine Roman construction as a place where each stone is carved individually for a specific place in the wall. But the Romans invented prefabrication, the manufacture of standard parts in advance before construction began. It was an approach that IKEA uses today, standardized parts that fit any structure. Roman bricks, tiles, pipes, and even columns were mass-produced in giant factories. There were strict standards for size and weight, which allowed architects to order materials without seeing them. Bricks from Gaul were a perfect fit for bricks from Spain, as long as they were of the same standard. This eliminated the need to adjust parts on site, saving a lot of time. Bricks were often stamped with the manufacturer's mark, the date of manufacture, and even the name of the person responsible for the batch. This was an ancient quality control system that allowed defects to be traced back to a specific factory. Builders knew which factories supplied the best products, and competition for government contracts was fierce. Mass production reduced the cost of materials, making stone construction affordable not only to emperors. Standardization applied not only to materials, but also to architectural designs and layouts themselves. The Romans developed standard designs for baths, temples, villas, and even entire city blocks. Engineers did not have to reinvent the wheel every time. They simply took a ready-made blueprint and adapted it to the terrain. This allowed new cities to spring up at an astonishing rate, like mushrooms after rain. Even decorative elements, such as column capitals or statues, were often mass-produced. Marble blanks were cut in quarries using templates to reduce weight during transportation. All that remained was to polish and install them on site, which significantly sped up the finishing work. It was an industry that operated on a scale that Europe would not see again until the Industrial Revolution. The use of standard sizes made it possible to calculate the required amount of materials in advance with high accuracy. This simplified logistics and budgeting, reducing the risks of corruption and theft on construction sites. The Roman bureaucracy strictly monitored expenses, and standards were the main tool of control. Deviations from the norm were considered sabotage or theft. Prefabrication also extended to wooden roof and floor structures. Beams of standard length and cross-section were harvested in forest provinces and floated down rivers to construction sites. Carpenters knew how to work with these standardized elements, assembling complex trusses quickly and reliably. It was a system that ruled out chaos and improvisation. Even lead pipes for water supply were cast in standard diameters, which simplified their connection and repair. There were tables of pipe capacity that engineers used when designing aqueducts. It was a level of technical documentation worthy of the 20th century. The Romans transformed construction from a craft into an industrial process. Thanks to this approach, a Roman city in Africa looked almost the same as a Roman city in England. This created a sense of a unified cultural space and a feeling of home for the traveler. Wherever you found yourself, you knew how the city was organized and what to expect from its architecture. But how exactly did the Romans plan these cities from scratch, transforming the wild steppe into an orderly metropolis? In the next chapter, you will learn about the method that turned the chaos of nature into perfect order. The Romans did not build cities haphazardly, obeying the curves of rivers or hills, as the Greeks or Celts did. They imposed a rigid, uncompromising grid on the landscape, known as centriation. This was not just a layout, but a sacred act of ordering the world, transforming the wilderness into a civilized space. The main streets, the Cardo, north-south, and the Decumanus, east-west, intersected at right angles, forming the skeleton of the future city. The tool used for this layout was the groma, a simple but accurate device that allowed perfect right angles to be constructed. Surveyors or agrimensors were elite specialists whose work was equated with a sacred ritual. They divided the territory into equal square blocks, or insulae, which were then built up with houses. This grid was so accurate that its traces can still be seen on satellite images of European cities today. This layout solved many problems before they even arose, such as navigation and addressing. It was impossible to get lost in a Roman city. All the streets were straight and parallel. This also ensured excellent ventilation of the streets, which were swept by winds, which was important in a hot climate. The order of the streets simplified the laying of sewers and water pipes under them. The city grid was not limited to the walls, but extended to the surrounding agricultural land. The fields were also divided into neat squares, which were distributed among veterans and colonists. This simplified taxation and land disputes, as the boundaries were obvious and indisputable. The entire empire was transformed into a giant chessboard. At the center of the intersection of the main streets was always the Forum, the heart of public and commercial life. Here were temples, the basilica of the court, the market, and administrative buildings. The Forum was a standardized element that was present in every town, even the smallest ones. It was a place where citizens felt their belonging to Rome. The city was strictly zoned. Noisy and dirty artisan quarters were moved to the outskirts or across the river. Elite houses were located on hills, where the air was cleaner and cooler. Cemeteries and dumps were always located outside the city walls for sanitary and religious reasons. The Romans understood the importance of urban hygiene and comfort. The modular system allowed the city to grow and expand easily by simply adding new neighborhoods to the existing grid. It was reminiscent of modern Lego construction, where each new element fits perfectly with the previous one. When the city outgrew its walls, they were demolished and new ones were built to encompass the expanded grid. Flexibility within a rigid structure was a brilliant solution. Even today, the layout of many European cities, such as Turin or Vienna, repeats the ancient Roman grid. Historic centers have preserved the street directions set by agrimensors 2,000 years ago. We walk along the same lines that the legions marched along without even suspecting it. This invisible legacy of Rome is under our feet. Roman urbanism was a tool for controlling and managing huge masses of people. Straight, wide streets not only allowed the city to be ventilated, but also enabled troops to be quickly deployed to suppress riots. The city was a machine for living, designed rationally and without sentimentality. Order on the ground began with order underground, and the Romans knew this better than anyone. Are you ready for the shocking truth about what really made the Romans civilized? It wasn't white togas, philosophy, or even laws. It was their sewer system. The Romans were the first to realize that a large city cannot exist without an effective waste disposal system. Without it, any metropolis would turn into a breeding ground for plague and cholera in a matter of weeks, dying out faster than it grew. The famous Cloaca Maxima, or Great Sewer, was one of Rome's first and most ambitious projects. Initially, it was just a canal for draining swamps, but later it was turned into a closed underground collector. It was so huge that, according to the historian Strabo, a cart with hay could pass through it. This underground stream carried sewage from the city to the Tiber River, saving the inhabitants from epidemics. Roman engineers developed a complex system of underground tunnels that ran under the main streets of the city. Sewage from public toilets, baths, and even the private homes of wealthy citizens was discharged into these tunnels. Water constantly flowing from aqueducts and fountains washed these channels, preventing sewage from stagnating. It was a self-cleaning system that operated around the clock. Public toilets, or latrines, were not a place of shame, but a center of social life where news and deals were discussed. They were equipped with marble seats and running water that constantly washed waste into the sewer. The Romans used sea sponges on sticks instead of toilet paper, which seems strange today, but was the norm. Cleanliness of the body in the city was elevated to a cult. Engineers carefully calculated the slope of the sewer pipes so that the drains would flow by gravity, but not too quickly. Errors in calculations could lead to blockages or pipe ruptures, so the design was entrusted to the best specialists. Manholes for access to the sewers were located on the streets, allowing slaves to descend for cleaning and repairs. It was dangerous and dirty, but vital work. The Roman obsession with water was evident not only in the sewer system, but also in the grandiose baths, or thermae. The thermae consumed enormous amounts of water, which also went into the sewer system after use, helping to flush it. Thus, the citizens' leisure activities also served the utilitarian purpose of cleaning the city. Everything in Roman engineering was interconnected and rational. Unlike medieval cities where sewage was poured directly onto the streets, in Rome the streets were washed with water. The sidewalks were raised above the roadway, and special stones were laid to cross the street. This allowed pedestrians to keep their feet clean even during heavy rain or street washing. The comfort of the urban environment was unprecedented. However, the system also had its dark sides. The Tiber was heavily polluted, and dangerous gases accumulated in the tunnels. Floods occurred periodically when dirty water from the river flowed back into the sewers and spilled onto the streets. But even with these shortcomings, Roman sanitation remained unmatched until the 19th century. Europe forgot these technologies and paid for it with terrible epidemics. The Romans proved that civilization begins with hygiene and the ability to handle waste. Their engineering genius was as evident underground as it was in their magnificent temples. The invisible infrastructure was the true foundation of their greatness. But how did the Romans deliver water to the city to make this whole system work? In the next chapter, you will learn about an aqueduct that operated solely on gravity. Aqueducts are rightly considered the hallmark of Roman engineering and a symbol of man's victory over nature. To supply water to a city of millions, engineers brought water from sources located tens of kilometers away. These were not just ditches, but complex hydraulic structures where water flowed solely under the force of gravity. No pumps, just precise mathematical calculations. The greatness of these structures lay not only in their size, but also in their incredible precision. The Romans understood that water was life and treated its transportation with religious reverence. Builders erected kilometer-long stone arteries that connected remote mountain springs to bustling city squares. Every drop of water in the fountain in the Forum had traveled a long way before quenching the thirst of the townspeople. The main secret of the aqueducts was their perfectly calibrated slope, which was only a few centimeters per kilometer. If the slope was too steep, the water would destroy the canal with its turbulent flow. If the slope was too gentle, the water would stagnate, become cloudy, and become undrinkable. Finding this ideal balance was one of the most difficult engineering tasks of the time. Roman surveyors managed to maintain this microscopic angle for hundreds of kilometers, passing through mountains and over valleys. This required tools and knowledge that seem incredible for antiquity. They used special devices such as horibodi, which were long tables with water levels. With their help, it was possible to plan the route so that the water did not stop anywhere. Most of the aqueducts ran underground in special tunnels to keep the water clean and cool. This solution also protected strategically important water pipes from enemies who might try to poison or block the water. Underground channels required less maintenance and were not affected by wind or erosion. Only a small part of the entire system was visible to the public. Only when crossing ravines or rivers did the water come to the surface via the famous arch bridges. These arches became an aesthetic symbol of Rome, but for engineers, they were a purely pragmatic solution to save stone. The arch design allowed the enormous weight of the water and the gutter itself to be supported using fewer building materials. Beauty was just a nice side effect of efficiency. Inside the city, the water flowed into huge distribution reservoirs or castelli. Here, the flow slowed down to remove any remaining impurities before being fed into the city network. These were massive structures, often decorated with statues in marble, symbolizing the emperor's generosity. From here, the water began its journey to specific consumers. From these reservoirs, the water flowed through lead and ceramic pipes to fountains, baths, and the homes of wealthy citizens. The city's network of pipes resembled a tangled web hidden beneath the streets. Engineers used pipes of standard diameters to make it easier to calculate pressure and consumption volume. Lead was a convenient and soft material, although the Romans already suspected its harmfulness at that time. There was a clear hierarchy of access. Public fountains were supplied first so that any poor person could draw water. This was a guarantee of peace in the city, as a shortage of water could quickly lead to riots. Then public baths, which served as leisure centers, were connected. Private water pipes were the first to be shut off in the event of drought or accident. The maintenance of aqueducts was a task of national importance, for which a special water curator was responsible. This official had enormous power and reported directly to the emperor. He had at his disposal an entire army of specialists, from architects to simple diggers. They made sure that the great city never went thirsty. A huge staff of slaves and technicians constantly cleaned the canals of lime deposits, repaired cracks, and fought illegal taps. The water was hard, and limescale quickly built up on the walls of the pipes, narrowing the passage. Workers had to descend into narrow tunnels and manually remove this buildup. It was hard and dangerous work in complete darkness. Water theft was punishable by huge fines, as water was considered public property. Some enterprising citizens tried to break through the pipe and divert water to their villas or gardens. To combat this, there were special inspectors who checked the pressure in the pipes. It was a complex bureaucratic and technical machine. The Romans also used the principle of communicating vessels, creating culverts, pressure pipelines to overcome deep valleys. When it was impossible to build a bridge due to the excessive depth of the gorge, engineers resorted to physics. Water flowed down the pipe to the bottom of the ravine, accelerated, and rose under pressure to the opposite slope. It was a risky technology that required very strong pipes, so bridges were often preferred. The pipe joints had to be perfectly sealed to withstand the enormous water pressure at the lowest point. Expensive lead or even stone was usually used for such systems, but the very fact that such principles were used indicates a high level of hydraulics. Water quality was a matter of particular concern. Sources were carefully selected for taste, clarity, and temperature. Before construction began, doctors examined the local residents who drank from the source to ensure their health. If the people looked strong, the water was considered good. The Romans understood the connection between poor water and disease. The water was settled in special pools to remove sand, clay, and other impurities. The filtration system was multi-stage and thought out to the smallest detail. Romans consumed more water per day than the average resident of a modern metropolis. An abundance of clean water was a sign of high quality of life and hygiene. The aqueducts were built with such a margin of safety that some of them are still in operation today, supplying water to the fountains of Rome. The builders used a special waterproof concrete based on volcanic ash, which only became stronger over the years. This is a monument not only to engineers, but also to the will of the state, which put the good of the city above cost. Water was the lifeblood of Rome, and aqueducts were its veins. Without a constant supply of fresh water, the existence of huge Roman cities would have been physically impossible. Baths, sewers, and fountains required millions of liters every day. This system made it possible to create oases of civilization, even in the arid regions of Spain and Africa. Rome brought water to places where there was none. The Romans loved comfort as much as they loved water, and they had no intention of freezing even in the northern provinces. When conquering the cold lands of Britain or Germany, they brought with them the familiar Mediterranean comfort. They invented the world's first effective central heating system, known as hypocaust. This engineering marvel turned the floors in homes and baths into large, warm radiators. The Romans realized that heated stone retains heat for a long time and gently releases it into the room. Instead of burning fires in the center of the room, suffocating from acrid smoke and soot, the Romans hid the fire underground. This allowed the air in the living rooms to remain clean and fresh. The floor in a room with a hypocaust was raised on brick pillars, forming a hollow space about half a meter high. These pillars were called pilae and were placed at equal intervals to securely hold the heavy floor. In an adjacent room or outside, there was a furnace from which hot air and smoke were sucked into this underground space. The heat warmed the floor from below, spreading evenly throughout the room. The stones heated up and began to radiate a pleasant warmth, allowing people to walk barefoot even in freezing temperatures. This created an incredibly comfortable microclimate that was unattainable to other peoples of that era. The system was inertial. The floor took a long time to heat up, but then it could give off heat for a whole day. But the engineers went further. They built rectangular ceramic pipes into the walls. A simple warm floor was not enough in the harsh winters, so the Romans decided to heat the room from all sides. Hot air from under the floor rose through these pipes inside the walls. Passing through the channels, the air heated the walls and created a real thermal cocoon for the inhabitants. The room was heated evenly, without cold corners or drafts. The smoke escaped through a pipe on the roof, without entering the living quarters or staining the ceilings with soot. It was a radiant heating system, which is considered the healthiest and most efficient even today. The hypocaust required enormous amounts of fuel and labor, so initially it was used only in public baths, thermae. To heat the huge bathhouse building, mountains of wood and coal were needed every day. The thermae were veritable palaces of warmth, where different temperatures were maintained in different rooms, from the hot caldarium to the cool frigidarium. Later, wealthy citizens began to install such systems in their villas, especially in cold Britain and Germany. Having a warm floor in a private home was a sign of incredible luxury and high status for the owner. It showed that the owner could afford not only complex construction, but also the constant purchase of firewood. Ordinary people continued to warm themselves by simple hearths. The construction of a hypocaust required high qualifications. The floor had to be completely sealed so that smoke did not seep into the room. The slightest crack could lead to the poisoning of the inhabitants with carbon monoxide. The floor screed was made of special heat-resistant concrete with the addition of brick chips. This ensured that the floor would not crack from sudden temperature changes and would last a long time. Maintaining the furnace was hard work for the slaves, who threw wood on the fire and cleaned the ashes in cramped underground corridors. They worked in terrible heat and dust to ensure comfort upstairs. But for the masters in the living quarters, it was pure magic. The heat came from nowhere with no visible fire or dirt. The Roman elite were accustomed to walking around their homes in light tunics and sandals even in winter, enjoying the warm floor under their bare feet. They did not need to wrap themselves in furs and skins inside their own homes. This technology allowed the Romans to bring their relaxed Mediterranean lifestyle to the harsh climate of the north. They did not adapt to the cold. They aggressively changed their environment to suit their needs. Engineering allowed them to ignore the weather outside. Villas with hypocausts in England are proof that the Romans were not willing to sacrifice comfort for geography. After the fall of the empire, the secret of the complex hypocaust system was forgotten or became too expensive to implement. Europe returned to open fireplaces and hearths that only warmed the face, leaving the back cold. Knowledge of the principles of draft and thermal conductivity of materials was lost for centuries. The efficiency of Roman heating was only surpassed in the 20th century with the advent of modern radiators. Medieval castles were ice caves compared to Roman villas. This is yet another example of how far ahead of their time the Romans were in terms of domestic comfort. The Hippocaust was a symbol of the victory of engineering over climate, of technology over nature. It made the Roman home a fortress not only against enemies, but also against the cold. Construction on such a scale would have been impossible without a flawlessly organized supply system. Roman logistics was the invisible foundation of all their achievements, linking resources, production, and consumption into a single network. Engineers thought in terms of continents: grain from Egypt, tin from Britain, marble from Greece, timber from Germany. All of this was transported across the empire with clockwork precision. The main transport artery was the Mediterranean Sea, which the Romans proudly called Mare Nostrum. Our sea, specialized cargo ships, corbetas, carried hundreds of tons of cargo in a single voyage, which was significantly cheaper than land transport. The Romans built giant ports such as Ostia and Portus, equipped with warehouses, lighthouses, and even dry docks. Rivers were also turned into transport channels, where barges were pulled by oxen or slaves walking along the shore. This allowed heavy building materials, such as stone and timber, to be delivered deep into the continent. Logisticians calculated routes to minimize transshipments and downtime. The system was so efficient that famine in Rome occurred only for political reasons or due to storms. On land, the state postal service Cursus Publicus operated, providing transportation for officials and important cargo. Along the roads were horse-changing stations and inns, strictly regulated by the state. Every travel document was recorded, and officials knew who was going where and with what cargo. It was total control over the flow of resources. The Romans invented the amphora, a standard container of antiquity, ideally suited for maritime transport. Amphorae were tightly packed into the holds of ships, saving space and protecting the cargo. There were standards for volume and shape for different products: wine, oil, fish sauce. The fragments of millions of amphorae formed the entire mountain of Testaccio in Rome, a monument to ancient consumption. Powerful cranes with pulleys, driven by human power inside huge ratchet wheels, were used to lift heavy loads in ports and on construction sites. One such wheel could lift a multi-ton block with millimeter precision. The mechanization of loading operations was at the highest level for the pre-industrial era. Supply contracts were concluded with private companies, publicans, but the state strictly controlled their execution. Failure to meet deadlines or delivery of poor quality grain could result in execution or exile. Suppliers were personally and fully responsible. Corruption existed, but the system as a whole functioned smoothly. This global logistics network created the first common market in history. Prices for goods at different ends of the empire were equalized, and Roman citizens had access to goods from all over the world. Globalization is not a 21st century invention, it is a Roman legacy. Without this logistics, Rome would have remained hungry and naked, unable to maintain its army and build cities. The transport system was the glue that held the empire together. The Roman Empire fell 1,500 years ago, but its engineering legacy proved more durable than its legions. We still live in a world shaped by Roman standards and technologies. The width of railroad tracks in many countries can be traced back to the width of a Roman cart axle. Our laws, our architecture, and even our languages are steeped in Rome. Roman roads became the basis for modern highways, and many modern cities stand on Roman foundations. London, Paris, Vienna, Cologne, all began as Roman military camps or colonies. Their historic centers retain the layout drawn up by Roman surveyors. We walk in their footsteps, often without even realizing it. Concrete, invented by the Romans, has become the main building material of modern times. Arch bridges and domes, principles of water, supply and sewerage. All this has been rethought and improved, but the basis has remained the same. The Romans showed that engineering can be an art and an instrument of state policy. The main lesson of Rome is not in technology, but in approach, organization, standardization, and discipline. They proved that great deeds are not done by lone heroes, but by a well-oiled system. Their ability to scale solutions and apply them across vast territories remains unmatched. It was a triumph of reason and will over chaos. Roman ruins are not just beautiful stones for tourists, they are blueprints of a civilization that knew how to build for centuries. They remind us that quality and durability are choices we make today. Will our cities be able to stand for 2,000 years and inspire admiration in future generations? We learn from Rome not only how to build, but also how to manage complex systems. Their experience shows that infrastructure is the skeleton of society, without which it cannot stand upright. Investments in roads, water, and comfort pay off handsomely, creating the foundation for prosperity. Rome is gone, but its engineers remain with us. A piece of their genius lives on in every water tap, every concrete wall, and every straight street. We are the heirs to their construction site, continuing their endless work. Their ambition to rebuild the world to suit themselves was bold, but it succeeded. Rome became an eternal city not because it cannot be destroyed, but because its ideas cannot be forgotten. We saw that the secret of Roman speed and quality was not magic, but precise calculation, strict standardization, and military discipline. They turned construction into an industry and cities into a standard product available to every citizen of the empire. The Romans did not wait for nature to be kind to them. They picked up their tools and built their world, stone by stone, road by road. Their legacy teaches us that real progress is impossible without order and a systematic approach. What topics from the history of ancient technology would you like to see in future issues? Perhaps the secrets of the Egyptian pyramids or the engineering wonders of China? Write your suggestions in the comments and be sure to subscribe to the channel to continue this journey through time with us.